So if you go to your Blackboard, in the content folder you'll see practice exams. There is a sample midterm one. I'll upload another one, and we can solve this. So we'll solve this one today. Yeah. We'll solve this one today, and then the next one we can solve on Monday. No, when is the exam? Tuesday. Yes. So next one we can discuss on Monday. Okay, so let's start. This is the first problem. It says consider the following grammar S, A, C, and so on. Prove or disprove that the grammar supports a predictive parser. How will you do that? How will you prove or disprove? Yes? Not really. We saw a method in the last few slides of the syntax analysis. Then can anybody tell me what you do to prove or disprove that the grammar supports a predictive parser?
A generates alpha and B generates beta, then take the first of alpha and intersect it with the first of beta, and it has to equal the ampersand.
So then what is the first step that you do?
You need to find the first of alpha.
You have to find the first and the follow sets.
Yeah.
Okay. So let's do that. So this is how a sample exam looks like. That you'll have possibly 4 or 5 questions. Here I have got 4 questions. Yes. You'll possibly have 4 or 5 questions. Typically you'll have 4. Each will be either 25 points, or here this one was 20, this is 30. So I'll specify which ones have how many points. And then you will have all the first and follow sets listed here. The rules for the first and follow set. Right? So you can look at those rules. Now you can also have a cheat sheet. 1 page, front and back. You can write in it, you can type in it, don't care. Right? So 1 sheet you can have. Now don't try to type all the slides in it, because otherwise you yourself won't be able to read. So let's start doing this. Let's do it on the board. So I'll copy the grammar, and then we'll just have the rules there and start doing the first and follow sets. So the grammar is S goes to A, C. So S, A are all non-terminals because they are capital, and small c is a token, that is a terminal. So A goes to small a, capital A goes to capital B goes to small b, and capital B can also go to epsilon. Right? So this is our grammar. So let's take a look at the first set rules, because I myself follow. Okay. So what do? We create a table. We create a table and we want to calculate the first sets of S, A, and B. These are the non-terminals. Right? These are the non-terminals, so we want to calculate the first sets of this. So the first step to do this is what? You give everything empty. So initially everything is empty. That is your first step for calculating first sets. So then the next thing that you do is now try to calculate the first of S. So let's try to calculate the first of S. So what is first of S? Does the first rule apply? Is S a terminal? Is not a terminal. So first rule does not apply. The second rule, no, because S is not epsilon. The third rule, does it apply? A goes to X alpha. Is there some rule like that?
Yes.
Which one?
AAC.
AAC, right? Where is A? What is X?
AA.
Can X be AA?
Absolutely.
What is X? X is a non-terminal, right? X has to be a non-terminal. Alpha is a sequence of non-terminals, terminals, and so on. X can be either terminal or a non-terminal, right? So what is X in this case? So we are applying the rule 2, that A goes to X alpha, and to the rule, we are applying this to the rule to the production rule, A goes to AAC. So what should be our X? Yes? X is A. A is S here. Alpha is this thing. Right? So if we apply that, then what is the rule? It says that, okay, take first of A minus epsilon, add it to first of S. Right? So first of A is empty, you delete the epsilon, nothing happens. So by applying this rule, nothing happens. Right? It remains empty. Can we apply the rule number 4? What does the rule number 4 say? Yes. Pardon? What file? It's at the end of that same file, midterm question. So it is in the page. What page is it? Anyone knows? 7. Page 7. Go to page 7. You have all the rules there. Okay, so does the rule number 4 apply?
No.
Why not?
Doesn't have epsilon.
All the non-terminals do not have epsilon, right? So 4 does not apply. 5? Five also does not apply. Nobody has epsilon. Everything is empty. So rule 5 does not. So after this iteration, we get that S remains empty. What about A? First of A. We are now calculating first of A. So X is a terminal. Is A a terminal?
Small a.
Yes, small a. So we have first of A. We can apply the rule 2 and say that the first of A at least has this small a. Although we are not done yet. So it has small a, right? First of A has small a. Now can we apply some other rules? Can we apply the rule 3 to the third production rule? So we want to apply this rule. Rule 3 means A goes to X alpha, and the production rule to which we are applying that is A goes to B, right? So what is our A? A is A. What is X? X is B. What is alpha? Alpha is epsilon. Right? So what is the rule? What does the rule say? The rule says that you add first of B minus epsilon to first of A. What is first of B? It's empty. So it doesn't change anything. Can we apply rule number 5 to any of the production rules? No, say rule number 4 to any of the production rules. Cannot really add, right? Even if it applies, it doesn't change anything. Similarly, rule number 5. Can we apply rule number 5? No, nothing. So A remains, the first of A remains A. Now let's consider B. So B, can we apply rule number 1? Yes, B goes to small b. We can apply there. Can we apply rule number 2? Yes,
Yeah.
because B goes to epsilon. We have that rule. We apply rule number 2 to that. If we won't even see other rules, because even if we see other rules, it is not going to change B in any way. Right? Because of the production rules that it has, neither can add B or epsilon. We have already added them, so there is no point in looking into the other rules. Do we go one more step? Yes, because something changed. So let's go one more step and let's see S again. So we cannot apply rule 1, we cannot apply rule 2. Can we apply rule 3? So again, how do we apply rule 3? So A, what is the rule? Rule is A goes to X alpha, and we are trying to apply it to the rule S goes to AAC, right? So now we say that A is S. What is X?
A.
X is A. Alpha is this 2 AC. So now what does the rule say? The rule says that, okay, you take first of X minus epsilon, add it to first of A, which means you take first of A minus epsilon, add it to first of S. So first of A is A, does not have epsilon, so you cannot really delete epsilon, but you add it to S. So S now has A, right? Can we add any other rule? Let's see. So can we apply rule 4? Because why not? Because A, we can apply it to the production rule S goes to AAC, but first of A does not have epsilon. None of the first have epsilon. So we cannot apply rule 4. We cannot also apply rule 5. Because first of A does not have epsilon and first of C also does not have epsilon. Right? So rule 4 and 5 cannot be applied. So S has the first set of S is just A. Right? Then first set of A, we can apply rule 1, but it won't change anything. We cannot apply rule 2. Can we apply rule 3?
Yeah. Yes.
Yes. What is X in rule 3?
B.
X will be B and alpha is epsilon, right? So if X is B, alpha is epsilon, what does the rule say? The rule says that first of B minus epsilon to add it to first of A, right? So first of B minus epsilon, B has epsilon, so you add B to A. So now the first of A becomes A comma B, right? Can we add any other rule? Rule number 4. No, yes. Can we add rule number 4?
Yeah.
How can we do that?
Because B generates epsilon.
Yes, B has first of B has epsilon, but then there is no A plus I plus 1, right? Pardon? Yes. So you cannot apply rule 4, but maybe you can apply rule 5. And turns out that yes, you can apply rule 5 because B has epsilon. Right? So if you have rule 5, then that means you have to add epsilon to first of A. You add epsilon to first of A. Any other rule that applies? No other rules. Right? Okay, now let's compute first of B. Will first of B really change? And you can try applying those rules, but none of them will apply, basically. So first of B does not really change. Do we go another step? Yes. So again we will compute first of S. So what is first of S? 1, 2 does not apply. 3 applies. 3 applies, but it doesn't really change anything. Oh no, it does change, right?
Yeah.
It does change. So what you do is you add first of A minus epsilon to first of S. First of A has changed. So now you add B also to S. You understand why we add B? Anybody has doubts, problems? Okay. Can we apply rule 4?
Yes.
Yes. We can have I equals 0, right? I equals 0 means first of A has to have epsilon. Does it have epsilon?
Yes.
Yes, it has. So what do? You add first of AI plus 1 minus epsilon to S. What is AI plus 1? A. So nothing changes because you already added first of A. Now you do I equals 1, right? So if you do I equals 1, then you have to have A0, first of A0 has to have epsilon, first of A1 has to have epsilon. Both A0 and A1 in this case are A, right? So A0 also has epsilon in it, first of A1 also has epsilon in it. So what you do? You do AI plus 1. You add the first of AI plus 1 to minus epsilon to S. So what is AI plus 1?
C.
C. What is first of C?
C.
C. So you add C to S. Right? You add C to S. Okay, does the rule 5 apply? Rule number 5?
No.
Why not?
C is not.
It's because you have C. C does not have epsilon. All the A zeros through AK should have epsilon. Right? Here C does not epsilon. Does not have epsilon. So now let's go and do A. First of A, will it change? It won't really change first of A. And so first of B will also not change. So those are the first sets. Do we have to go another step?
No.
We have to, right?
Yeah.
Because this just changed. So any change, we have to go first. So we go another step. So S, first rule does not apply, second rule does not apply. Even if third rule applies, you don't really add anything. So the only thing that you could potentially add is the epsilon, right? That is the only thing that you can add. So which rule adds epsilon? The rule number 5. So you just check for the rule number 5. So the rule number 5 says all the A's should have epsilon in the first step, but C does not have. So you cannot change. So S does not change. Similarly, A does not change and B does not change. Right? So you do another level, but you just copy and paste the same thing. So since it does not change anymore, we don't go any further. So the first set is this. So let's recopy or just ABC, AB. Okay, let's rewrite it. I wrote it correctly, right? Is that the one that we got? Okay.
Yes.
Now we need to calculate follow sets. So these are the rules in the follow set, right? So what is the first thing that we need to do to compute follow set? We have to calculate the first sets. We have already done so. So no need to do it again. So let's this we want to calculate follow of S, A and B. So these are follow, right? So follow the rule is again you make it empty, right? The next rule is if S is the start symbol, you have to add the end of string or end of file character to the follow of S. Right? That is the first rule. So follow of S at least has the end of file character. Now let's go and discuss the second rule. So can I apply the second rule to the first production rule? Even if I apply, it won't change the follow of S, right? It will change the follow of some other non-terminal, but not S. So no point in applying that rule. Similarly, rule 3 also. Rule 3 does not change the follow of S. Rule 4 also does not change the follow of S. And so rule 5 also does not change, right? So no other rule applies. So we will keep the first set of follow set of S as the end of 5. Now let's discuss the follow set of A. Which rules do we look for? We look for all the rules that have A in it. So first one, this one, then this one, then this one. Right? We have to look for all of them. So let's check the first production rule. S goes to AAC. Right? Can we apply the first rule? Does not apply because A is not S. Can we apply the rule 2? So we are trying to apply A goes to alpha B to the production rule. S goes to AAC. Can we apply that? No, right? Because in order to apply that rule to this production rule, capital A has to be the last non-terminal. That is not the case. So we don't apply that rule to this. Can we apply this rule to the next production rule? Can we? Somebody says yes, somebody says no. No, why no? Because capital A is not the last non-terminal. So we cannot apply that rule. Can we apply that rule to A goes to capital B? For the same reason, no. Right? So that the rule 2 cannot be applied. Can we apply it to rule 3? So now we are trying to apply rule 3. So rule 3 is what rule? Rule 3 is A goes to alpha B, A1, A2, and so on to AK. And we want to apply that to the rule S goes to AAC. Can we apply? Is it possible to apply? Why not? Now let's first see whether we can, you're right, but let's first see whether we can map it. Right? Whether we can map that rule into S goes to AAC. Can we map that rule to S goes to AAC? No? He says yes. What if we map it like this? That capital A is S, alpha is epsilon, B is A, A1 is this, A2 is C. We can map it like this, right?
That is incorrect.
Why? Yes, but AI through AK can be terminal as well. They can be non-terminal or terminal.
Can alpha be epsilon?
Yes, alpha can be epsilon. Alpha is a sequence of non-terminals, terminals, and epsilon. I through or A0 through AK can be non-terminals or terminals. Yes.
How come you can apply the epsilon being alpha but not in the last step?
Which one?
The step before this goes A goes to I can't remember here, but
No, so yeah, A goes to alpha B, right?
yeah.
So there alpha can be epsilon, fine. But capital A has to be the last non-terminal.
So like then we apply if A goes to B.
But then B is not the B is the last terminal, not capital A. We are calculating the follow set of capital A, right? So that capital A should be the last terminal, last non-terminal in any of these rules.
Okay.
So this rule, capital B is the last non-terminal,
So
not
for
capital
B,
A.
that would work.
Yeah, so yeah, when we are doing B, then we will take a look at that. But not now. You had a question.
Oh, so if it's just a capital, then it's a non-terminal, but if there's a subscript, like A sub I, then it could be terminal.
Terminal or non-terminal.
Okay.
So that way we can apply. But as she says that the rule itself does not apply. Why? Because the rule says that okay, you have to have epsilon in all of the AIs through AKs. You don't have it. A1 is capital A, right? We don't. The first set of epsilon of A has epsilon, so that works. But C does not have it. C does not have epsilon. So you cannot really apply rule 3. Now can you apply rule 4?
Yeah.
You can apply rule 4, right? Using the same mapping, you can apply rule 4. So what does the rule 4 say? It says that you add the first of A1 minus epsilon to the follow of B, right? What is B here? B is capital A. What is A1? A1 is also capital A. So first of A1 is AB epsilon. So you minus the epsilon and you add AB to the follow of B. So that means follow of A will have AB, right? So let's write AB here. Do you understand how we can apply rule number 4, right? Can we apply rule number 5 to that same rule? S goes to AAC.
Oh wait, for still this one for rule 4, can we move it back? Like alpha equals to A and B is
Oh
A.
yes. So yes, we are not done yet. Good catch. So we are not done yet because we can apply rule 3 in another way. We can apply rule 3 in another way. What way can we apply? A goes to capital S, fine. We can apply it in another way. Let's say B goes to A, alpha goes to capital A, and A1 goes to C. That can be another way of applying, right? So in that case, what happens? So if we try to apply rule number 4, then it says that okay, you have to add first of A1. So A1 is C, right? You have to have first of A1 minus epsilon to the follow of B. B is A. So first of A1 is what? C. So you have to add C to follow of A, right? So you have to add C to follow of A. You had a question. Somebody had a question.
Alpha doesn't have to be terminal.
Pardon?
Alpha doesn't have to be terminal.
No, it can be a sequence of non-terminals, terminals, or the empty string.
So do we always have to check with the empty string?
Pardon?
So do we always have to check with making alpha
Of the empty
epsilon
string.
first?
Yes. Oh, wait, there are a lot of questions. First, you.
So we have to try all the different mappings and then
Yes, we have to try all the different mappings, and then before that, he had a question.
my question was actually pertaining to how rule 4 applied. I guess I just missed it a little bit.
How rule 4 applies?
Yes.
Okay. So how rule 4 applies is that you have to first do a mapping of that rule into the production rule, right? So there can be many mappings. One of the mapping is this, that alpha goes to capital A, capital B goes to capital A, A1 goes to C. That is one rule. Now when after you have done that mapping, then what you do is you check A1. You take the first of A1 blindly. You don't see whether epsilon is there or not. It does not matter. Blindly take first of A1, delete the epsilon from that set, and add it to the follow of B. What is B here? B is A. Right? That's how it applies.
And then the first of A1 is C, so C is added to A.
Yes. Yeah, wait. You had a question.
Is the capital B in the rules just non-terminal or everything like A is like is it a non-terminal?
No, in this case, when we are computing follow sets, capital B has to be the non-terminal that you are interested in.
Yeah.
Right?
But the A's are.
Yeah, A's can be anything. But capital B has to be the non-terminal that you are interested in. Yeah, she had a question.
So alpha cannot be anything.
Cannot be?
A sub k is can be anything.
Yes, A sub k can be anything. Alpha can also be anything.
So why not use alpha instead of A?
Alpha can be a sequence also. A cannot be a sequence. I mean, A subscript I cannot be a sequence. Alpha can be a sequence. Yes.
So if you want to do this algorithmically, apply all the mappings, how would we proceed? Would we just start with alpha as epsilon and then try to
Expand alpha.
expand alpha?
So yeah, you proceed alpha as epsilon. All this time, when you are expanding alpha, you have to keep in mind that capital B has to be the set that you are interested in. So you cannot have alpha that is AA and B as C, because that doesn't make sense. I mean, doesn't work for you, because you are not calculating follow set of C. You are calculating follow set of A. So you have to have some mapping such that capital B is the set that you are interested in. Right? That's why we did not apply the rule 2 to A goes to capital B. He was saying, right, that why can't we apply the rule 2 to A goes to capital B, that production rule. We could have applied, but then in that case our B would be B, but we are calculating follow set of A. Right? So we are not interested in that. We have to map in such a way that our B in that rule is a non-terminal that we are interested in. Right? Okay, so we add C by doing which one? The rule number 3. Rule number 4, yes.
Yeah.
Now, does any other rule apply? Even if it applies, it doesn't make any change, right? Because all ABC is there. What else can be there? The end of file. That is the only thing that can be there. So who adds end of file? End of file will be added if we are only considering the rule 1, right? The production rule 1. Anything related to production rule 1 will add end of file to us, because end of file is there in the non-terminal S. So if we have like add follow of S to something, then only we will get end of file. Otherwise we won't. So what rule adds follow of S to follow of A? Yes, the rule 2. So can we apply the rule 2 to S?
Yes.
Can we?
No.
What will be alpha? What will be B? Alpha is A, B is C. But does it add to the follow of A? In order to add to follow of A, B should be A. So okay, let's take alpha epsilon, but then B becomes a sequence. B cannot be a sequence. B has to be a non-terminal. You understand that part? So alpha B means B is a non-terminal that we are interested in, right? B cannot be a sequence. So if I take alpha as the empty string, then that rule does not map. Alpha we have to take AA and then B becomes C. But then that does not really change follow set of A. So end of file we cannot add to follow set of A as of yet. We will see whether we can add later. But now we cannot add. So we are done. We are done with the follow set of A for now. Everybody understood how we got follow set of A? Hey, are there any doubts? Anybody has problems with this derivation? No doubts? Okay, we'll move on, but then if you have doubts, you can ask questions. So let's see what is follow set of B, right? We cannot apply rule 1 because B is not the start symbol. Can we apply B goes to alpha B for any production rule? Can we?
The third one.
How? No, the second rule. I'm saying the second rule, can we apply to any production rule involving B? Which one? Yes, we can. A goes to B, we can apply. Right? So what is alpha? Alpha is epsilon and capital B is B. Now what is the rule? You have to add the follow of A to follow of B. Right? So which means whatever follow of A had, you have to have that in B. So B now has A, B, C. Right? You add follow of A to follow of B. Everybody understood? Everybody understands how we get A, B, C in the follow of B?
No.
Who said? You said no. Okay.
No, it wasn't me.
Oh, you said no. Okay. So let me reiterate.
I don't know how you apply that rule to it. I thought you need an alpha and something.
Yes. So how do we apply rule 2? So we are trying to apply rule 2, which is A goes to alpha B. Right? This is the rule we are trying to apply. To which production rule? To the production rule A goes to B. Right? We are trying to apply it. So what we can do, how we can apply is A goes to A, B goes to B, and alpha goes to the empty string epsilon. So I mean we can rewrite this rule as this: A goes to epsilon B, right? And we know that concatenating epsilon with anything else keeps it the same, right? So that's how we apply the rule. Any other doubts, problems? Okay. Now we have. Oh, you have a question.
Can be on the right side be a epsilon?
If it is epsilon, then it does not matter to us. And it can be epsilon. But if it is epsilon, it does not matter to us because we are not computing follow set of epsilon. We are computing follow set of B, right? So capital B has to be whatever non-terminal we are interested in. So if you are calculating follow set of A, capital B has to be A. If you are calculating follow set of S, capital B has to be S. And if you are calculating follow set of B, capital B has to be B. That is the thing that we do. Okay, so now ideally for a very studious person, what he or she should do is go over all the production rules and all the rules and all the production rules and see what happens to capital B. But we want to take a shortcut. What is the shortcut? The shortcut is B already has ABC. What else will B have? B can have just the end of file. Which rule adds the end of file? The rule 2. The rule 2 is the only rule that can add end of file to B. So we will just look at rule 2. Can rule 2 be applied now? Rule 2 we have already applied to A goes to capital B. So applying it again does not give any new result. Can we apply to anything else? Any other rule? Yeah.
Why don't we wouldn't add it?
Pardon?
Wouldn't add it again?
If we add it again, it remains the same. Union. If you do A union A, it is A. Right? So, is there any other production rule where we can apply rule 2? There is no other. So, we are done with B. Do we go another round? Yes, because something has changed. So, let's go to S. Right? So, the first rule we have already applied. We have got results. The second rule. If we apply the second rule, we can only apply it to just the first production rule, right? S goes to AAC. Yes.
So that was the one that we did. So, she would have checked rule 4 and 5 or we did not check?
Which one?
Rule 2, that was rule 2, right? So did you check rule 3 through 5 or not?
So that's what I'm saying. That if there is a studious person who wants to be absolutely sure, he or she should check 3, 4, 5. But we took a shortcut.
You could take that.
We can take that because we know that the only terminals that can be added to B are A, B, C and end of file. A, B, C's are already added.
One is the only one that.
Pardon?
One is the only one that.
One is only what?
You said the only other option is the file. And that can only be added by rule 1.
Either one or two. Now one you cannot use because B is not the start symbol. Can you use rule 2? So that's why we only checked rule 2. Right? So that's how we took a shortcut. Now let's talk about S again. So first rule we have already applied. Can we apply rule 2? Even if we apply rule 2, nothing changes. I mean, we won't really change anything in S. We'll change something in B, but we don't care. Can we apply rule 3? Even if we apply rule 3, the follow set of S does not change. Can we apply rule 4? Again, same argument. Even if we apply rule 4, follow set of S does not change. Similarly, rule 5, follow set of S does not change. Right? So S remains the end of file. Now can follow set of A change? The only change that follow set of A can have is addition of a end of file. Right? Who can do that? Rule 1 cannot be used because A is not a start symbol. Only rule 2 can be used. Right? So can rule 2 be used anywhere for A? Cannot be because A has to be the last non-terminal and none of the rules say is the last non-terminal. Right? So you cannot use rule 2. So A remains the same, A, B, C. Pardon? What? Yes, there is no rule that A is the last non-terminal. But that is not small a. We want capital A as the last non-terminal. So this is a terminal, that's not the non-terminal. Does B change? Again, B can only change by adding end of file. So end of file can be added either by rule 1 or rule 2. Rule 1 does not apply. Rule 2 kind of applies when we take A to B. But since the follow of A does not have end of file, you don't really add end of file to B. So B also does not change. So B is A, B, C again. So we are done with follow set because nothing changed. So now we have the first and the follow set. Now we have to argue about whether there is a predictive recursive parser or not. Now let's try to see whether we have that or not. So in order to do that, let's copy the follow sets. Follow of S is end of file. Okay. Now what is the first condition of having predictive recursive parser? Yes. What is the first condition?
If A generates alpha and A generates beta, then first of alpha intersect first of beta equals empty set.
Good. So we first check all the non-terminals. So we have how many? 3 non-terminals, S, A and B. So for each non-terminal we have to see, are there any 2 production rules for the same non-terminal? Is there 2 production rule for S? No. There is only 1 production rule. Is there 2 production rule for capital A? There is. So we have to check. So what is the rule? The first rule says that if there are 2 production rules of the form A goes to alpha and B goes to beta, A goes to alpha and A goes to beta. And remember, these alpha beta are sequences of non-terminals, terminals, and the empty string. Right? So if that is the case, then then we should have first of alpha intersect first of beta equals the empty string, empty set. Right? We have to have the empty set. So in this case, we have these rules. These are the 2 rules. So A became we have these 2 rules. A is alpha and B is beta, right? What is first of alpha?
Little A.
Is little a. What is first of B? We know is B epsilon. Does it intersect? So we have to intersect this with B epsilon. What is the intersection?
Empty set.
Empty set. So this works. Is there any other non-terminal which has 2 rules? B has 2 rules. So what we have to do is, so these are the 2 rules. This is alpha, this is beta. What is first of B? B. First of epsilon is epsilon. So you intersect the 2. Empty set. So we are relieved that first rule applies. So that means we are 1 step closer to having a predictive recursive parser. What is the second rule? What does the second rule say?
If epsilon is in the first of A, then first of A intersect all of A equals empty set.
So what we will have to have is we look for all the non-terminals and we say whether epsilon is there in the first of any non-terminal, right? So what we see is that yes, capital A has epsilon, right? And capital B also has epsilon, capital S does not. So we'll have to check for both. So what was the rule?
A if epsilon is in first of A, then first of A intersect follow of A is empty set.
Have to be empty set, right? That is the rule. So now let's check for A. So is it epsilon is in first of A? If you intersect first of A and follow of A, what happens? It's not empty, right? So then you, after doing so many things, you found out that this grammar does not have a predictive recursive person. Just for the sake of completeness, you can compute intersection of first of B and first of and follow of B also. Not empty. So this grammar does not have predictive recursive person. Yes.
Are the rules to figure out if it has predicted recursive descent parser also going to be given to us, or do we have
No.
that? Okay.
So this is the sample midterm, right? So this is what you have.
Okay, cool.
So everybody understands the solution to this one? Yes.
For the midterm, do you want us to show the step by step for the first and follow, or can we just show the sets?
You can show the sets, but if I see that you just wrote first and follow, then I'll assume that you copied from somewhere. So you have to show how you arrived it. So that is 20 points. Here, this, yes.
So in terms of showing our work, can we just do the kind of like, we show what's in the follow sets at a certain time and then in the next set?
Yeah, just
So we don't
what
have to
I
write
did.
down the rules and compare them and map them out?
Just what I did.
Okay.
Just the same thing you do. And you don't have to write down the rules, compare it, map it, all those things. Those are for the understanding. But you just do what I did. Yes? Long for the-
The entire class.
Oh, the entire class. Yes, you have the entire class. Yes. Okay, now the next question. The next question says, consider the following grammar with first and follow set. So we already give you the first and follow sets. You have to write the parse function. Right? Now this one is extremely easy. What you do is you just follow the method that we wrote. Right? So I'm not going to discuss this one because you just go to the slide, it's all in the slide. Just remember what you have to do from the slides. So I'm not going to do this one. If you try this, if you can't do this, then on Monday we'll discuss. Okay, let's do this one. So consider the following code in C syntax. So you have to assume static scoping and dynamic scoping and output the results. Okay. So let's do that. So can you take, let's say, maybe 2-3 minutes to try and understand what will be the results of static scoping? So do that and give me the result. Does anybody have the result for static scoping? Yes.
I got 10, 10, 20.
10, 10, 20. Well, let's write it here. So she got 10, 10, 20. Okay. So let's see whether that is right. So int I, that was global. So whenever you're here, in main you did I equals 10. Which I was it modified? The global. So you modified this one. So now global I is 10. Now you come inside here. Which I is this one? This is the local I inside this scope, right? You come again here. You define I equals 2. What is this I? This is again local within this scope. You call foo. The moment you call foo, the scope goes away, right? For C static scoping. So whenever you take this variable I, which I is it pointing to? What? I heard local from somebody. It's not local, it's the global. It's C static scoping, right? So it is going back to that global. Right? Because, why? Because this particular scope is nowhere to be found now. If you call this function, then this scope goes away, the function scope comes in. You haven't defined I inside this function. So if you haven't defined I inside this function, the default scope is the global scope, right? So now global I is 10, so yes, you print 10. This one is right. You print 10. Then you come back. When you return from this function foo, you come back to this scope. You make I equals 100. Which I is this? I again heard global from somebody. Which one? Which I is this? Local I, right? Local I means this one. So this I becomes 100. So if this I becomes 100 and you go out of scope, then that I went out. It gets deallocated from the stack, right? Now when you call this function foo, before calling this function foo, if you had something to do with I, which I would it point to? The local, this one, right? Just before calling that function. Now once you call this function, you are out of scope of this block. So you go to foo, you haven't defined I inside foo. So which I does it point to? Which one? Global, yes. Now let's say G and L, because local and global sounds the same thing to me. Let's say G and L, right? So in foo, you call I, so this I is the G, Gi, right? So the global I has the value 10. So that is also right. Now you come out of this one. So that I is gone. You are updating this I. Which I is this?
G.
The Gi, right? Because here in main, this is the main scope. You haven't defined I. So if you don't define I, it goes back to the global. So now this I becomes 20. Now you call foo. Foo goes here. There is no I defined, so I falls back to the global, and you print I. So I is 20. She gets 2 points. Right? So that is the result for static scoping. Anybody has problems with this? Everybody understands? Now the fun begins. Let's do dynamic scoping. Now, how do we do dynamic scoping? We have discussed this in the class, but let's go step by step. So whenever you have dynamic scoping, you have to have a symbol table. What did that symbol table have? It had the name, type, and which, if it was a function, which line it was defined in, and then it had some value, right? So let's start by looking at that function. In the global there is an int I, so you have a symbol table entry. The first symbol table entry is you have I and its type is int. You don't know the value yet, right? You don't know the value. Then you have a function foo. So you have another entry. This is the function foo. It has a, yes, the input type is void and it is declared in line number 2.
Could you use like the green or black?
You can't see it, right? Okay, I'll use the black. Now you come here in int main I equals 2. Which I should it change? No, I equals 10, sorry. Which I should it change? Whichever is the most recent. Right? You go to the symbol table, you say I is here, this is the most recent I. So change that I. Right? So this I's value becomes 10. Right? So this one change this I. Then you come in this scope and you declare int I equals 5. Yes.
We don't have to add int main to the stack, do we?
Int main.
Yeah.
Oh yes. Yes. We do. No, we don't need to delete anything. Line 5. Yes, that's a good catch.
Shouldn't that be int
Yeah.
instead of void?
No, function signature, remember, is the input arguments, not the return type. Return type is not a part of the function signature. That's our semantics. That's how we define it. Function signature is name and input arguments, not output, not return type. Then we have int I equals 5. This is a new scope. So whenever there is a new scope, we need to put an arrow and add this there. So int I equals 5. So I becomes an int and the value is 5. Right? So this goes here. Oh no, this is yes, this is an assignment. Then we have another scope. So the moment we have another scope, we have another arrow and we say int I is in, the value is 2. So this one goes here. Now we call foo. Do we delete anything from the symbol table? Not yet, because it's still in scope, right? Still in scope. So we call foo. Foo does what? It does printf I. Which I?
The latest.
Which one?
The newest one.
The most recent one. Most recent one means this is a stack. So last in, first out. What was last in? This was last in. Right? So now this print I, the first time it does print I, it goes to, it refers to this one. So what the first output that you'll get is the value 2. That is the first output you get. Then you return. You make I equals 100. Which I?
2.
That's 2, right? So this I equals 100 updates this one. So instead of 2, Now it became 100. Now you go out of scope. What happens? That last I goes away, right? So you delete this one. Now before you delete this one, let me take picture. So you remove this one. You are done.